All right, for this question, we have two sets, and we have the universal set of natural numbers that are less than 11. So natural numbers are counting numbers. So we're going to write out that set to help us with this problem. Okay, we're going to stop at 10 because since we're doing less than 11, we don't include 11. These symbols, the apostrophes, mean prime, which means not in the set. So when I find A prime, it's everything not in this set, but in the universal set. So when I list these out, I have 1, 2, 3. I'm skipping 4 and skipping 6, 9, and 10. And then B prime is everything not here, but in the universal set. So 1, 2, 6, 7, 8, 9, and 10. And then this symbol means intersect. So that's what overlaps between these two. So what's overlapping between these two groups? They both have a 10, they both have a 9, they both have a 6. So there's 3 elements that intersect, 6, 9, and 10. So that's choice D. Number 44, the probability of event A is 0.41, the probability of B is 0.67, the probability of event A and B, this symbol means and, is 0.08. Round the answers to the nearest 1,000. What is the probability of B given A? So this symbol here is like the given that symbol. For your reference sheet, we have a formula on here that is going to help us. Okay, so you don't have to memorize the formula, you have to find it on your reference sheet. The top is how they intersect, okay, whatever intersects, and then the bottom is going to be the second part, right? So this says the line and then B, so we're going to put B in the bottom. So for this problem, the order switched around from our formula, right? It says B given A. So when we do our formula for this one, we're going to have the probability of the intersection, and this time we're going to put the probability of just A in the bottom because A comes second. So based on what we have up here, we're going to have 0.08, and we're going to divide by the A, so divide by 0.41. And then we just divide that in our calculators. So 0.1951. That's the first one. The second one, you notice these are switched around, so that means B goes in the bottom, but the top's still the same. So I'm going to put 0.08 on the top, and now B is going to go in the bottom, 0.67. So we're going to divide that and get 0.1194. Okay, and then the last one says, are events A and B independent events? So we have to test to see if they're independent. And the way we test to see if they're independent is we can see if the probability of A is equal to the probability if we do given that A then B. So there's 3 ways we could test this out, and either of these ways would be acceptable. So we can test if A is the same as A given that B, which it's not the same because we figured this out and they weren't the same values, so they're not independent. Or we can test if B is the same as B given that A, they weren't the same, so they're not independent. Or we can test if the intersection is the same as A times B. So we would have to multiply these two together, and the answer we get is not the same. so they're not independent. You can pick either of these ways to test it. It doesn't matter which one. So they're not independent. All right, number 45. 45 says a survey was done asking 1,000 people their movie preference and age group for advertising purposes. The table below shows the movie genre, so these are the genres, and the age group, less than 30, more than 30, and then we have a total column. This says, what is the probability of A for action? So if I want to find the probability for action, we're going to do 289 divided by 1,000. And we can leave it as a fraction.